All right, welcome guys. So today is day 4 of the semester. Today's Thursday the 14th. This video will be on Thursday for B Day, and it'll actually be next Wednesday the 20th for A Day because they're a little behind. So today's assignments will be a warm up. We'll do that in class together, so I'm not going to have that in the video. Actually, let's do it in the video. That way I don't have to do it over and over again. So that'd be good. Transition metal ed puzzle. I'll try to make that short. I'll try to have like a question or two from each slide. So I'll try to make it short. And then we're going to have transition metal classwork where we practice the concepts that we're learning here. This will be due next Friday. So we're still talking Unit 5 on naming compounds. Today we're going to review how to write the formulas, how to use polyatomic ions, and then we're going to talk about how to name ionic compounds. Today we're going to focus on naming compounds with transition metals. It's a little different. It's not bad, but it's a little different. And then tomorrow will be a B day as well, and tomorrow we will have a quiz. For A day, y'all's quiz will be, I'm thinking next Friday. Let me look at that. Yeah, because there's no school Monday, the 18th. So you guys will do this lesson on next Wednesday, and then y'all's quiz will be Friday. So next Friday for A Day. Okay, so quiz coming up. The quiz is about halfway through the unit. I want to kind of just let you guys practice and see what you need to work on. And then we've got 2 more days of stuff to cover for this unit. We got to talk about covalent or molecular compounds, and then we've got to talk about acids, how to name acids. All right, and then we'll have a test at the end of the unit as well. All right, so let's jump right in. So the warm-up for today, so basically I showed you guys this. It just says use the resources on this page to name or write the formulas for the compounds and the warm-up on Canvas. So I'll put the questions on Canvas in a quiz like we've been doing. Here are all the charges. Okay, so this applies to everything before transition metals, which we'll do today. So this is everything that we've covered so far. Keep in mind, you've got to be able to look on the periodic table and get the charges of the elements. Group 1, hydrogen down is +1. Next group is +2. We skip these because their charges can vary. We'll talk about these today. Group 3 is +3. Group 4 is ±4. And that's except for the ones at the bottom. Okay, like lead down here, he's in group 4 technically, but some of these guys down here are also considered to be transition metals. So you got to be careful with that. And let me actually kind of circle them. So I don't know, maybe these guys right here, these are the transition metals. So even though some of them are over in this group here, right, they're in the carbon group like lead, it's still a transition metal, so it can have more than one charge. Okay, so many of these, so like this group here is ±4. That really mainly applies for the guys at the top. So like carbon, silicon, especially the top 2, they're going to follow that rule. They're going to have a ±4 charge. Same thing with boron and boron and aluminum. They're going to have a +3. Nitrogen and phosphorus, -3. Oxygen and sulfur, -2. Fluorine, chlorine, bromine, these guys all have -1. And then these guys have no charge. All right, just keep in mind that these guys down here underneath the stair step, again, it's kind of these guys here, can have some weird things happen. So I almost consider these to be transition metals here. Okay. And this also includes the bottom 2 elements on the periodic table as well, okay? All right, and then we're also going to use our list of polyatomic ions here to do the warm-up, okay? All right, so let's try some examples. Aren't you excited? I'm excited. Use resources, so here's the periodic table again. All right, what is the formula for the strontium arsenide? All right, so strontium arsenide, I'm going to look on my periodic table. I'm going to find strontium, which is group 2. and I'm going to put his charge. So strontium plus 2. And then arsenic. Arsenic is right here. It's underneath phosphorus, and it's a -3. Okay. So that's my charges. I write the symbol for them. I put the charge, and then I cross the charges. So I rewrite this. I write SR. I put a box there. I write AS. I put a box there. And I'm going to change the color of my pen. So everybody see this 3 here? The 3, but not the minus, will come down, and it'll go right there. So that turns into a 3. The 2 right here will come down and go right there. So that's what I mean by crossing the charge. And so this is SR3AS2. That's the formula. All right, and if you think about it this way, we need 3 strontiums will give us a +6, because each of them is a +2. So that's a total +6 on the positive team. On the negative team, the negative Nancy's, the arsenic has -3. There's 2 of them. And so it's a -6. And so remember that when you balance the charges for these 2 ions in a compound, think about it as 2 teams that are scoring. They have to have the same score. It has to be a draw. Nobody can win. Okay? Because when I write the formula for this right here, notice that there's no charges. And so that's another thing I see students do is they'll write the formula for this guy like this. And they'll keep the charges in there, but those charges cancel out, so get rid of them. All right. All right, so that's the first. That's number 1. The answer is SR with a little 3, and then an AS with a little 2. So that's what you want to pick. And when you write the formula for this on some of our virtual stuff, you may not get to do the subscripts, but that's fine. I mean, if you write SR3AS2, I'll know what you mean. Okay. All right, let's do number 2. Are you still excited? Why not? Okay. Magnesium chloride. Magnesium is Mg with a +2. Chlorine is a -1. So we're going to cross the charges. That'll become MgCl2. Let's double check that. Mg +2, and I got 2 chlorines. Is it equal and opposite charge? I got a +2 over here from that 1 magnesium, and I got 2 chlorines, each a -1. That's a -2. So we're good. Happy face. So MgCl2, we do not need to put a 1 there. So don't put a 1 there. Just put Mg and it means 1. All right. Number 3, calcium phosphide. Calcium is Ca with the +2. Phosphorus is a -3. Let's cross those charges. Ca3P2. And that'll be our formula. Remember that the 2 from the calcium comes down and goes to the phosphorus. The numbers are switching places. And then the 3 here will come down and go to that calcium. So Ca3P2. Calcium phosphide. All right, next one. NaNO3. Okay, now we're going to go backwards. We have been doing the formulas. Now let's write the name. I know that this is sodium on the periodic table, so I'm going to go ahead and write sodium. Okay. Now we need to pull in our ions, our ion list. So let's look at our ion list here. And we're going to look for that NO3. So let's go back to the warm-up here. We're looking for NO3. NO3. I know that's not an element. I know that's a polyatomic ion. So I'm going to go to that here, and let's find it. See if we can zoom in a little bit. Anybody see it? Nitrate. All right, so I'm going to call that the nitrate. Let's go back. This right here is sodium. So I'm going to write sodium. And it's not supposed to be capitalized, but I usually capitalize it for some reason. And then nitrate. Okay. And you got to keep in mind that there's nitrate, which is this one. There's nitrite, which is this one. And there's nitride, which is that one. That's the 3 that you'll see for nitrogen. All right, next one is calcium sulfate. What's the formula? Or I'm sorry, what's the name of CaSO4? And you can tell I've been doing this so long that when I see that, I just say the name. That's what I see. I see calcium sulfate. Is that not what you see? So this is calcium. And then SO4 is on our polyatomic list, and it's called sulfate. So if you switch over to your polyatomic list, you'll see sulfate. And so I'm going to put sulfate. I think it's spelled with an F. Let me double check that. Why is this not popping up? Oh, here we go. Sulfate. There's sulfate right there. 1 sulfur, 4 oxygens, and a -2 charge. Okay. So calcium sulfate. All right, halfway there with the warm-up. Number 6, what's the name for AlPl4? See, I almost did it again. I almost just named it. So aluminum is in group 3. So aluminum is actually, we don't even need to do the charges. We just need to identify the 2 parts. That's Al, so I know that that's aluminum. And then if you look on your polyatomic list, PO4 with the -3 charge, or 3 minus charge, remember that we write it opposite. That's phosphate. So aluminum phosphate is the answer. Okay. What's the name for NH4NO2? NH4 is called ammonium. And that's the first part of this. This is one of those weird compounds where the metal and the nonmetal places are both ions from our ion list. So NH4 is ammonium, NO2 is the nitrite. If you look at your list. So NO2 with the -1, and ammonium is NH4 with the +1. So that's ammonium, that's nitrite, and so that's what I'm going to write. Ammonium, nitrite. Now keep in mind that the charges that you see in the list will disappear. So if you look at your polyatomic list for phosphate, it shows PO4 with the -3, right? But when you look at it in the formula, the -3 is gone, and that's because it cancels out. It is no more. Same thing here. Okay, so number 7 is ammonium nitrate. Let's look at number 8. Strontium perchlorate. We want to do the formula. So strontium is Sr. It has a +2. Perchlorate, if you look on the thing, perchlorate is ClO4-. And you really do need to practice looking at that polyatomic list and getting them. That's the only way that you'll be able to do these on your own. And so that's a -1. And so I'm going to cross the charges. The 2 from the strontium comes down to tell me that I need 2 of that perchlorate ion. And then the 1, this is a 1 there, comes down to strontium. So I just need 1 strontium. So if I get rid of that 1, that's our formula. Sr parentheses ClO4, and we need 2 of those perchlorate ions to balance, right? Because strontium is a +2, so that's a total +2. If I have perchlorate on the other side, on the other team, I need 2 of them to make a -2. They have to have the same score. All right, so that's strontium perchlorate. Number 9, ammonium nitrate. Ammonium is NH4+, and nitrate is NO3-1. So you could cross the charges if you want to, but when I put the 2 symbols next to each other, I immediately just look and see if they're going to balance. I got a +1, a -1. We're good. Just put them together. NH4 and O3. Okay. Now make sure that you're checking the charges and seeing that they're balanced. Don't just put the 2 ions together. Okay. Like an example here, if I said name aluminum phosphate. That's not a good example. Let's do aluminum sulfate. So I want to write the formula for aluminum sulfate. Well, what students will do is they'll say, okay, aluminum is Al and sulfate is SO4. So there's my formula. Well, that's not charge balanced. Aluminum is a +3, sulfate is a -2. You do not have equal and opposite charge, so that does not work. What you will end up with is Al2SO43 when you cross the charges. So make sure you're crossing the charges and not just sticking them together. Sometimes you can get away with sticking them together, but sometimes you can't. So you have to check. All right, ammonium nitride. Ammonium is NH4 +1. Nitride is actually just nitrogen, and it's got a -3. So anytime you have IDE in a name, it just means an element, one element. So that nitride is just nitrogen. Oxide is oxygen. Phosphide is phosphorus. Okay, it's the eights and the ites that are different things. So I'm going to cross the charges here. I'm going to put NH4 in parentheses. This 3 on nitrogen has to come down. So I'm going to put a 3 there. And then the 1 has to come down for the nitrogen. So that's a nitrogen. So our final answer will be NH4 with parentheses around it with a little 3. You need 3 of those ammoniums and then the nitrogen. So there's our formula. Okay, there's our warm-up, guys. Make sure you click everything and submit. And keep in mind that the warm-ups are a major part of your grade. Okay. Okay. Review. Here's some key points, okay? So keep in mind that "ide" usually means one element. All other endings, ate, ite, us, ik, all of these endings are for polyatomic ions only. So "ide" is reserved for one element. So if the ending of a name is IDE, look on the periodic table, okay? And this will save you a lot of time if you're paying attention. If it ends in ate, ite, us, ik, or do not look on the periodic table. They're not on there. Ammonium is not on here. Carbonate is not on here. So if you waste your time looking for it, it's going to really suck, okay? And I've seen students do that, okay? All ionic compounds must be charge balanced. That means equal and opposite charge. +1, -1, +2, -2, +3, -3, +4, -4. All right. The name of the ionic compounds never indicate the numbers in the equation. For example, MgCl2 is called magnesium chloride. Notice how we don't mention the fact that there are 2 chlorines in the formula. And so I keep saying this, and the reason I keep saying this is because when we do the next kind of naming, you have to indicate the number. Okay, and let me just give you a quick example of that you can relate to. You guys know what the name of this is, right? CO2. Y'all should know that that's called carbon dioxide, right? Guess what the di means? Di means 2. So for these kind of molecules with 2 nonmetals, they're called molecular or covalent compounds. You have to indicate the name. And so when we do ionic compounds with a metal and a nonmetal, we never indicate the name. Shake your head. Okay? All right. And I'm just a little delirious because it's the end of the day. I'm ready to go home. So here's a list of polyatomic ions that have nitrogen in them. There's nitrate, nitrite, and nitride, and ammonium. And here's the descriptions of each. Notice that if it says NO3 with a minus, that's the way that the ion looks. What does that mean? 1 nitrogen, 3 oxygens, and a -1 charge. The 3 is not for the charge. Notice that the 3 is a subscript. It's kind of down, and it's kind of small. So that is the number of oxygens. That 3 belongs to that O. So it says 3 oxygens. And then the minus up here tells us that the whole thing is a -1 charge. So what that means is it's NO3, and the whole thing is a -1 charge. That's what that means. So you've got to be able to interpret these correctly. This one right here means 1 nitrogen, and it's got a -3 charge. We just flip the 3 and the minus. Okay? This is 1 nitrogen, 4 hydrogens with a +1 charge. So that's +1. All right. Here are sulfur polyatomic ions. There's sulfate, sulfite, and sulfide. Again, remember that IDE means monoatomic element. That means it's an ion with one element, monoatomic, one atom. And I know when I use those words, it gets confusing, but one element for ide, okay? Phosphorus, phosphate, phosphide, that's a -3 there. I missed the minus. And then, so phosphate is that, phosphite is that, and phosphite's actually not on your polyatomic list, so you probably won't see it on the test or anything, and I'll have to look for it and make sure it's not on there, but that's the phosphite molecule. And then phosphide is just phosphorus with the -3 charge. So that's one phosphorus with the -3 charge. All right. Hydroxide is a very common one. It is one oxygen and hydrogen. So think about that name, hydroxide. Hydro means hydrogen. Oxide means oxygen. So hydroxide with -1, very common molecule. One oxygen, one hydrogen with a -1 charge. Here's our carbonate. One carbon, 3 oxygens, and a -2. This is actually in Tums, so I actually appreciate this molecule a lot because this molecule soothes indigestion and heartburn. So this is the active ingredient in Tums. Or maybe you'll see it in like other things that'll kind of help upset stomach. So thank you, carbonate. Chlorine, so here's some chlorine molecules. Perchlorate, chlorate, chlorite, hypochlorite, and chloride. This fourth one is actually the main ingredient in bleach. So this is these are kind of nasty, kind of pretty dangerous chemicals. Notice that chloride is just chlorine with a -1 charge. So keep that in mind. Anytime it ends in ide, that's going to be one element with a charge. Chromium, here's some chromium ions. Here's some positive chromium ions. So this is chromium 3 and chromium 6. So we'll talk about these in a minute. But these are two that are on the polyatomic list. Okay, so now let's get to new stuff. So what do we do if an ionic compound contains a transition metal? For example, FeCl2. Well, if we look at what we've learned so far, we know that groups here +1, +2, +3, +4, and so on. But iron is right here. And all of these guys, we have no rules or no way to determine the charge, right? Because most of the elements that we've already done, you can look and see where they're at, right? If I had a compound that had barium in it, well, I just look for barium right there, and I say, okay, he's got a +2 charge. Easy. But what about iron? Iron's in the middle here. So what do we do with them? How do we determine the formula of a compound if we know it has iron in it, but we don't know the charge on iron? So let's look at that. And again, the transition metals are all right here. And again, it kind of dips down into here. So these are kind of transition metals as well. And then these are transition metals as well. That means that the charge can vary. For example, iron can be a +2, or it can be a +3 in other molecules. So there's different molecules that both have iron in them, but they have different charges. So how do you determine that charge? Okay, we have to determine the charge by deduction, and I'm reading right here. We have to determine the charge by deduction, and we have to ask ourselves, what must the charge be equal to in order to make the formula have a net zero charge? Charge balance, equal and opposite charge. So if I have one iron with some charge, and I have 2 chlorine ions in the formula. All right, so the example that we're doing here is FeCl2. What is the charge of iron in this molecule? Okay, that's what we want to know, and then we want to write its name. How do we name that if we don't know the charge of iron? Okay, so let's figure out the charge on iron. I have 2 chlorine ions right here, and so I know that the total minus charge is a -2, because each of them has a -1. And I know that the iron, the metal side of this, has to have an equal and opposite positive charge. So I got one iron atom, and so that iron atom has to be a +2. okay, because it has to balance with the other one. So if I replace this question mark with the +2, do I have equal and opposite charge? Well, on this side you got a +2, and on this side you got a -2. We are happy. Equal and opposite charge. Okay. Okay, the next step of this, so we're going to call this iron chloride. We're going to put parentheses, and we're going to put something in that parentheses to indicate the charge. I'm going to show you how to do that. That's the last step of this. So we have to figure out the charge of iron by deduction, looking at what the negative is, figure out what the positive is. Okay. All right, so how do we indicate the +2 on the iron? We use Roman numerals. So here's Roman numerals 1 through 5. 1 looks like this, 2, 3, 4, and 5. All right, and that's really the only ones you need to know. You might see 6. 6 looks like this. 7 looks like this. 8 looks like this. 9 looks like this, and 10 looks like this. But really, 1 through 5 are pretty common. So I would be familiar with them. What does this 2 tell me? Does it tell me Fe2Cl? No, it does not. It tells me that the charge on iron is a +2. So that tells me that this is iron 2. It's a type of iron that has a +2 charge. Okay. Keep in mind that the 2 in parentheses from that name indicates the charge on that iron, charge on the metal. Like I just said, iron 2 is not Fe2Cl3. Iron 3 is not Fe3Cl. If I say iron 2 chloride, I mean iron 2 with chlorine, so that's FeCl2. And then what do I mean here? Iron 3 chloride. That means iron with a +3, and then the chlorine with a -1, so that means FeCl3. So that's iron 2 chloride, or I'm sorry, iron 3 chloride, and this is iron 2 chloride. What's in parentheses tells us the charge on the metal, on the iron, not the number of irons in the compound. Okay? We have to indicate the charge on iron because it's a transition metal. Transition metals can have many charges. Iron can be +2 or +3, so here's 2 iron compounds. So FeCl2 is iron 2 chloride because that charge on the iron is a +2. FeCl3 is called iron 3 chloride because the iron is a +3. All right, let's look at some more examples. What is the name of this guy? FeCl3. Well, we have to indicate the charge, so we know it's going to be iron something chloride. So you guys notice how we're indicating the charge in the parentheses? Keep in mind you only have to do this for transition metals. You do not need to do this for sodium or potassium or hydrogen or any of the other elements that aren't transition metals. There's no need because we know what the charge has to be. They only have one option from their location on the periodic table. So FeCl3 means we have 1 iron, right? If I write Fe, that means Fe1. Then I got 3 chlorines, each a -1. So what is my total negative? My total negative is -3. So what does the charge on that iron have to be? It has to be a +3. And so how do I indicate that? I use the Roman numeral 3, iron 3 chloride. Beautiful. All right. Another example, PbO, lead. Like I said, if you look on the periodic table, it's a little confusing, but lead is in a weird area in the periodic table. Lead is on group 4. So you might say, oh, lead's right here. He's in group 4. He's always ±4. Not really. Lead is actually still a transition metal, even though he's kind of over here. So these guys down here are still transition metals because lead can have a +2 or a +4 charge. All right. So let's look at him. I know we got the oxygen. Oxygen is always a -2. And then I got the lead. So I got 1 to 1. I got 1 lead. I got 1 oxygen. I got to balance that charge. So I know that that lead must be a 2. So I'm going to write lead 2 to indicate the charge, and then oxide. So that's the name of that one, lead 2 oxide. Ooh, look at this next one. Tricky, tricky. All right, last example, I think. I think I got one more slide. Let's name this guy. Ew. Okay, so that is called 10. The symbol for SN, the element is called 10. And it's in that zone. It's actually right next to lead. It's right there. So it's above lead. Like I said, these guys are transition metals. Okay, and I don't know if you guys can see that, but those guys are transition metals. We want to name this. So we know it's going to be 10, and then we're going to put something in parentheses, and then this PO4 is a phosphate. So I know we're going to put phosphate. Okay, but the question is, what do we need to put in the parentheses? What goes right there? Well, if we look at our formula here, let's look at what we got. I have 4 phosphates. Everybody see the 4 there? So I got 4 phosphates, each of -3. Holy crap, that's a lot of a negative charge. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is a -12. So the total negative charge is -12. I got 3 SNs, and they have to add up to a +12. So what do each of those SN atoms, what do they need for that charge? +12, so that's 12 divided by 3, which is 4. So each of them requires a +4 charge. All right, let's add these up. 4 plus 4 plus 4 is 12. 3 plus 3 plus 3 plus 3 is 12. Equal and opposite charge, so there we go. It's 10-4, which sounds like 10-4, right, from the military. But it's 10 with a charge of +4, and so we're going to put 4 in here. 10-4. Okay. And again, 10 is just a metal, like a tin can, and that's the symbol SN. Okay. I hope this is helpful, guys. Let's look at the next one. All right, so some old habits are hard to break. So these are names, so these are formulas here. These are the systematic names. So this is what I need you guys to know. So make sure that you can go back and forth between these two. Copper 1 chloride means that the charge on copper is a +1. Copper 2 chloride tells me that the charge on copper is that. Mercury +1, mercury +2, iron +2, iron +3. So these are the ones that I need you guys to know, forwards and backwards, where you're using the Roman numeral, right, like we just talked about. The common name we're not going to use. All right, so if you guys Google some of these, if you look for CuCl and you Google the name of that, you might find copperous chloride, but that's an old name that we're not going to use. And so for me, since I'm teaching you guys the systematic way with the Roman numerals, if you provide this as an answer, that's incorrect, right? Because I didn't even show you guys how to get those. All right, so make sure that you're using the Roman numerals to indicate the charge, because that's the current way to do it. This is an old school, outdated way of doing it. It's still out there online. It's still in the textbooks, but we don't use it much. Okay. All right. Our assignments, make sure you guys did the warm-up. We have a transition metal ed puzzle I need completed today. And then we have transition metal classwork, which will be due next week. All right. So each time we do some kind of lesson, we're going to have a warm-up, maybe an ed puzzle, and then certainly classwork to practice it, because that's the only way you guys will get good at this, is practice. All right, guys, that is all I have. Thank you guys for your time. Have a great rest of your day.